Can AI read my mind? I'd be more concerned if another person can read my mind using AI. Jokes apart, when it comes to AI, nothing seems too far-fetched these days. But this next story is less about AI and more about humanity. Here's a story that sounds like science fiction, but isn't. It's about AI, but it's not dystopian.
Researchers in Sydney have built an AI-powered decoder that translates brain signals into words. Using sensors embedded on a wearable electroencephalogram cap, this experimental device detects the brain's electrical activity. That information is conveyed to a monitoring unit on which a deep learning AI decoder interprets and translates the signals into words. A large language model is then used to refine the decoded text and correct possible errors. The final selection of words are then displayed on the monitor.
Spoon.
The model is in early stages of development. It's been trained on a small set of words and sentences to simplify the process of recognizing each word. The concept of brain-computer interface isn't new. There are a number of systems in development that connect the human brain directly to machines.
In simplest terms, a brain-computer interface is a device that senses brain activity, specifically your intention to move your hand, and sends that information out of the head and gets translated so that it can drive a computer.
The most famous example is Elon Musk's Neuralink, that uses a tiny chip implanted directly into the brain through a surgical procedure. The Neuralink chip has been successfully implanted on 3 individuals who are able to control devices like cursors or video games with just their thoughts.
We currently have a clinical trials in the US for a product that we call telepathy, which allows users to control phone or computer purely with their thoughts. And not only have we launched this clinical trial, but we also have an approval to launch this trial in Canada, UK, and the UAE.
Very simply put, what the Neuralink device does right now is it allows you to control devices simply just by thinking. Now, to put that a bit more concretely, I'm about to play a video of our first user. His name is Noland, if you remember from DJ Section. And what Noland is doing is he's looking at a normal off-the-shelf MacBook Pro. And with his Neuralink device, as you're going to see, he's going to be able to control the cursor simply with his mind, no eye tracking, no other sensors. And what's special about this particular moment is this is the first time someone is using a Neuralink device to fully control their cursor.
It's very exciting stuff, and I'm really happy to be a part of it, and I'm happy that they chose me.
Similarly, US-based Paradromics is developing a BCI system called Connexus, which uses a microelectrode array implanted beneath the skull. This device is designed to read neural activity with high precision and is aimed at restoring speech and movement in patients with severe neurological disorders. In comparison, the system being developed in Sydney is entirely non-invasive. A wearable EEG cap to detect brainwaves and an external AI unit to translate them into text without any surgery or implants. The results so far? Not perfect but promising. The AI correctly identified the target word about 75% of the time. Researchers are now aiming for 90% accuracy, a major leap for a device that relies on brainwaves alone.
As scientists, we look at a medical condition and we look at what function has been affected by that medical condition. What is the need of the patient? We then address that unmet need through technology to restore that function back to what it was. After that, the sky's the limit.
While all 3 BCIs have a common goal, the non-invasiveness and simplicity of the one being developed at the University of NSW makes it the most compelling prospect. The implications could be life-changing for stroke survivors, those with speech difficulties or paralysis. It's not hard to imagine wearable devices capable of translating thoughts into silent commands into augmented reality displays, or even interface that allows silent, thought-based communication.